In section 9, we are computing the areas of various geometric shapes. So we begin with the area of a rectangle and a square, and then we find the areas of parallelograms, triangles, and trapezoid, and then we have some applied problems involving rectangles and some other shapes. So we begin the discussion by looking at a square, what a square inch looks like, and a square centimeter by comparison. So in other words, each side is 1 inch long. For a square inch, 1 inch this way and 1 inch that way. And a square centimeter is simply 1 centimeter this way. Length and width are the same. So, to answer question number 1, what is the area of this region? Count the number of square centimeters. So there's 1, 2, 3, 4, 5, 6, 7, 8. So the answer is 8 square centimeters. 8 centimeters squared. Now, in general, the area of a rectangle with length L and width W is equal to the product of length times width. So that's the area of a rectangle. So when we look at number 7, find the area of a rectangle that is 7 kilometers by 8 kilometers. Well, the length is 7, the width is 8, and 7 times 8, so A is equal to 7 times 8, or 56 square kilometers. So notice when we're dealing with area, it is always something squared. Maybe it's kilometers squared in this, like in this example. And the next exercise, number 3, find the area of a rectangle that is 5¼ yards by 3½ yards. So here we would get square yards. So let's do this. So A, the area of this rectangular area is 5¼ times 3½ So we convert that into a fraction. So 21 divided by 4 times 7 divided by 2 so that's 147. 7 times 21 is 147 divided by 2 times 4, or 8, and that's equal to 18 3/8 square yard. Next is the area of a square with side length S, and that is equal to S times S, or equal to S squared. So let's apply this to next exercise number 4 here, and that is to find the area of a square with side length of 12 kilometers. So A equals 12 squared, and 12 squared is equal to 144 square kilometers. for exercise 5, we find the area of a square with side length 10.9 meters. So the area is 10.9 squared, which is equal to 118.81 square meters. So as you can see, to compute the areas of rectangles and squares, it's a pretty straightforward process. Number 6 is very similar. Find the area of a square with side length 3.5 yards. Again, the area is S times S, or 3.5 yards times 3.5 yards. 3.5 yards. So converting that to a fraction is 7 half times 7 halves, or 49/4. And that's equal to 12.25 yards, square yards. Next, we'll be looking at other areas. They're a little more complicated. So the rectangle and the square are pretty straightforward. Now we're going to look at a parallelogram. And a parallelogram is a four-sided figure with two pairs of parallel sides. So you could say that a square is, in a sense, a parallelogram because it has two pairs of parallel sides. Here's a square. Here's what most people look at as a parallelogram, or a little bit different angle, showed like this. And the rectangle can also be considered a parallelogram because it has two pairs of parallel sides. To compute the area of a parallelogram with base B and height h, we take the product of the length of the base and the height h. So the area is equal to base times height. So let's apply this to some exercises here. In number 7, area equals base times height. And the base is 7.3 centimeters times 6 centimeters. So that's 43.8 square centimeters. For the next exercise, we look at a parallelogram that looks a little bit different because here the height is kind of outside of the parallelogram, but that doesn't really matter. It's still the same calculations. A equals base times height. The base is 2.25 kilometers. The height is 5.5 kilometers. So the product is equal to 12.375 square kilometers. Next is the area of a triangle, and the area of a triangle is half the length of the base times the height. So 1/2 times b times h. Here's a triangle with base b and height h. Height h. So let's look at number 9. Here we have a triangle with base of 16 meters and a height of 12 meters. Therefore, the area is equal to 1/2 the base times 16 times 12 so it's 192 divided by 2. 6 times 12 is 192 divided by 2, and that is equal to 96 square meters, because the base and the height are given in terms of meters. And the guided solution, number 10, we're looking at a triangle where the base is 11 centimeters and the height is 3.4 centimeters. So therefore the area is equal to 1/2 times the base, 11 centimeters, times 3.4 centimeters. Therefore, we have 0.5 times 11 times 3.4, or 18.7 square centimeters. The next geometric figure we're looking at is trapezoids, and the trapezoid is a polygon with 4 sides, 2 of which, called the bases, are parallel to each other. So here we have the bases here and here. In this case, the bases are vertical, and here the bases are horizontal. And we compute the area of a trapezoid as follows. It's half the product of the height and the sum of the lengths of the parallel sides, the bases. So 1/2 times the height. The height is usually pretty obvious, and then the basis a plus b, or the area is equal to a plus b divided by 2 times the height. Whatever formula works best for you. So for number 11, let's be a little bit more explicit. Here the height is equal to 10 meters. And A is equal to 7 meters. And B is equal to 13 meters. So then the area is equal to 1/2 times the height times the sum of a plus b, which in this case is 1/2 times 10, height was 10, times 7 plus 13. So then A, the area, is equal to 1/2 times 10 times 20, 7 plus 13 is 20, and so that's equal to 10 times 2 times 10, that's 2 times 10 is 20, divided by 2, the 2's cancel, then 10 times 10 is 100 square meters. And when you do your exercises, I recommend you write down what H and A and B is, just to have clarity about what the variables represent. And then plug them into the formula. Either the first one or use the second one. In number 12, we do the same thing. We identify what h and a and b is. So h, the height, is 11 centimeters. A is equal to 6 centimeters. And b is equal to 10 centimeters. So here, let's use the other formula just to get a little variety how we do the calculations. A equals, the area is equal to a plus b divided by 2 times h, which means 6 plus 10 divided by 2 times 11, and 6 plus 2 is 16. Times 11, and 16 divided by 2 is 8, so it's 8 times 11, or 88 square centimeters. Let's look at some applied problems, and one of them is find the area of this kite. And the kite is 28.5 inches high, and it measures 8 inches this way and 8 inches that way, so it's 16 inches all across. And the best way to do this is to visualize as this being two triangles, with a base running from top to bottom, and here are the sides. Let me just draw that for you. So here we have two triangles, each with height h and base b. So the area of the kite is equal to the area of one of the triangles, 1/2 base times height, plus the area of the other triangle. Of course, that'll be the same, 1/2 base times height. Now the base is the height of is this distance here, 28.5, 1/2 times 28.5 times the height, and that's equal to 8 inches, times 8 inches, and then again 1/2 plus 1/2 times 28.5 times 8 inches. So that's equal to 1/2 times 28.5 times 8 is equal to 228, plus 1/2, again 28.5 times 8. Remember, we're having two identical triangles here, 228. And so 228 divided by 2 is 114. And 114 is equal to 228 square centimeters squared. So you may want to think about this yourself, maybe get a piece of paper and do it on your own, now that you know what the answer is, so you know if you came up with the right answer or not. That's it for the applied problems, and so this is the end of section 9.2.